Welcome everyone to the Metadata API webinar. It's part of our API series. If you haven't seen the other ones in this series, I'd recommend you take a look at those. We've talked about integration in a previous one and also the Service Cloud console. Before I go any further, I'm going to read this safe harbor statement line by line. Actually, I'll save you that, but I do need to talk about a couple of things here. Please don't make any future purchase decisions based on anything on this webinar, and only look at things that are currently available. So my name is Raj Chauhan. I'm within our Salesforce Services department. I'm joined by Srini Thirumalai. Both of us have a wide variety of experience, both small and large enterprise. We both have a particular passion for release management and specifically the Metadata API. So hopefully we can share some of the things that we've seen out there with our customers and help you be more successful with the API. So you can join Developer Force on various different channels here. You can follow us on Twitter, Facebook, Google+. I recommend you go there and interact with us and fellow developers. So here's what we're going to talk about today. Really, we're going to give an outline of what the API is, and then move into how can I access the API in terms of tools available on the platform. And quickly we want to move into Ant or the Force.com migration tool. Really, we see a lot of our developers move to that technology pretty fast. And then with the API, there are lots of things outside of the Salesforce ecosystem, but in the wider open source ecosystem that we find valuable. Things like version control, continuous integration, and build pipelines. Finally, we're going to look over the last couple of releases from Salesforce and share some features that we think are useful with regards to the API. So I've been working in the Salesforce ecosystem for about 4 years, and I'm not afraid to say I've looked like this sometimes on release nights. There's unpredictability, there's some risk, and usually it comes from not being well prepared when we're doing a release. Hopefully the things that we're going to show you in the further slides will help you avoid this picture. Let's start off with what I call the metadata home. So when you get a new Salesforce org, you get this kind of blueprint of a house with maybe accounts, contacts, and various other objects, and they come out of the box and they're ready for you to go. Let's imagine if you're building out your house here, you'll build a custom object. You can add some custom fields to that custom object, add some custom code, and even some custom workflows. And pretty soon you've got yourself a big picture of what your house will look like. And that's your metadata. As you build that out, that all comes across as metadata. So what is the API? Really, it's a text-based version of your org. So it's well-structured XML. And it covers everything from validation rules to custom objects to workflows. The tools that interact with the Metadata API are the primary drivers of how you make changes in your Salesforce org. Up until a couple of releases ago, everything was built on top of the Metadata API. I've got a slide at the end here about the tooling API, but that is another way to build some developer tools. But this webinar will be focused on the Metadata API. So the API is SOAP-based and it's asynchronous. The asynchronous nature is pretty important. It's a technique to poll for updates versus waiting for a deploy to complete. So there's two types of calls that you can use the API with. There's file and CRUD-based calls. So file-based calls are a coarse-grained call. So you'd call deploy, and deploy would refer to files on a file system. So it's a very coarse-grained, less granular call than the CRUD-based calls. So the CRUD-based calls are really something you can actually write in code. So if you wanted to create a custom field, you can write several lines of Java or C# or your programming language of choice to actually create more granular calls to the API. When we focus on Ant and some of the other technologies that we're going to cover in demos, we'll be covering the file-based calls, and that's what we see primarily out there with Salesforce customers. So if you've been looking at the API, you'll know that it's not complete, but we're certainly getting closer on every release. And with newer features, you can definitely see that they are API first. So here are some of those nouns that I talked about on the file-based calls and the CRUD-based calls. I'll draw your attention here to the utility calls. So the list metadata and describe metadata enable you to actually just see and interrogate what's in your Salesforce org. So here's an example of some metadata here. So this is a custom object. So I'll draw your attention to the top here. Your custom objects are like your database table. So we've defined a custom object named PTO request. We've got some fields. We created a PTO request name field. And then we can also see information about the schema. And you can just see here generally it's a well-structured XML document. Let's talk about the coarse-grained deploy flow here. We'll show a demo of this in a moment, but the flow will start here as a user. You'd call deploy at Salesforce. You've got some files on your file system that you're referring to. After you call deploy, Salesforce generates a async result object. That object also includes an ID. So when that gets returned, we can now start polling for updates. So we'd call check status with an ID. Once that is complete, Salesforce generates two more objects. One is a deploy result, which is kind of the header, and then you've got some deploy messages that are children of the deploy result object. Those deploy messages will contain things like code coverage results, code testing failures, just general information that probably need attention if your deployment has failed. We'll hand it over to Srini now. He's going to show us a demo of deploying using Ant.
Thanks, Raj. Hello, everyone. So here we are going to see how to deploy using Ant. So here you can see this is my dev org. And before I go with the demo, I just want to highlight the key components that you need to deploy using Ant. One is the Salesforce Ant.jar, which has all the APIs that you could call and then connect to Salesforce to deploy components. And the other three things are build.properties file, build.xml, and package.xml. So here, what I'm going to do is I'm going to deploy. I'm going to create a new component, new object in my developer org here. So here, what I'm going to show is I'm just going to show and then click on objects. So here you can see like there are no objects listed, but after once I complete the deployment, you would see a custom object in here. In the meanwhile, let's go and see like where we can find the Salesforce Ant.jar, from where you can download it. So when you look for tools, develop tools here, there is a list of all the tools that are available for Salesforce.com. And this is the Java Ant-based command line utility. This is what we want to talk about now. And just go ahead and download it from here. Okay, so let's go. And this is the terminal that I'm connecting to. And this is basically a command line utility, as I said earlier. So there is a command called Ant, and then in the build.properties file, you will have like multiple targets. I have a target called Ant deploy, so which I'm going to run it now, and which would create a custom object in my developer org here. So let me go ahead and deploy it. So you could see like, and the main thing that I want to talk about is the async pattern that Raj spoke about in the earlier slide. And you can see the ID. Once when I do this, Salesforce sends me an ID, and then my terminal would keep looking for this ID with Salesforce.com to confirm whether it is completed or not. Now, we know the request has been completed here, and what's the time that it has taken. So here, let's see. Now, as we have run, now we should see this.
I can do it. Great.
Yeah, sure. Go ahead, Raj. So here you can go ahead and see where this objects, the new objects that I have created. Now you can see the new object. So this is how you deploy a component into your developer org or any org using Metadata API. Thanks, Raj. Please take it from here.
Great, thanks, Rennie. So let's talk about some tools that can access the API. Before we get into that, I want to cover an interesting concept here. Draw your attention to the bottom there. So we've got the main metadata API. On the left-hand side, we've got Eclipse, which is primarily a development tool, but can also be used for deployments. Srini just showed the Force.com migration tool here. And on the right-hand side, you can see the ISV customers can use packaging to upload and then make those packages available for install via the App Exchange. Up the top here, if you've used Workbench before, it's a user interface that can also be used for deploying between Salesforce orgs. That's actually built on top of the Force.com migration tool. Again, change sets on the right-hand side here. It's change sets are a UI-based deployment tool. That's all built on top of packaging. So it's an interesting concept. We've got tools built on top of tools. So how do we deploy using the Force.com IDE? We would select our files, right-click on the selected files, choose Force.com and deploy to server. Salesforce will always ask you for credentials or never cache those credentials. And then general best practice here on step number 3 is to back up both your destination and your source org. Salesforce will then interrogate those files and let you know what's been added, what needs to be overridden, and then it will also show you things that haven't changed at all. Finally, clicking next, you'll get a success, and then you get a deployment result. If it wasn't successful, you'd get some messages there telling you what needs attention. So what do we like about the IDE? The IDE is a great as a single place for developers. It can easily traverse metadata files. And we'll talk about the package XML in more detail, but you can generate your package XML automatically. Some of the concerns we have around using the IDE as your primary interaction with the metadata API is that it's got no automation available. It's really hard to govern what and when things change. It can certainly become tedious for repeated deployments. For example, if you've had some failures, you need to select all your files again and deploy them again. Quite importantly, it doesn't run tests automatically between your sandboxes, and you must migrate whole objects versus individual fields. So if you remember the difference between the coarse-grained and the fine-grained calls, an example would be you've got 3 fields in your source org, and you only want to deploy one of those fields. The Force.com IDE wouldn't be a good fit for that. So usually we see the Force.com IDE as primarily a development tool. It's useful when maybe the developer and the release manager are the same person. It can certainly be used as a deployment tool. So I mentioned change sets earlier. The main components of change sets are in the source org, you'd create an outbound change set. In the target org, you'd create an inbound change set. And once again, this is all in the Salesforce user interface. This is all built inside the Salesforce platform. And to connect organizations, you need a deployment connection. What do we like about change sets? It's certainly a great user interface. It doesn't require a developer skill set. It handles dependencies. So, for example, if you choose an Apex class, Salesforce will interrogate that class and find out all the fields or maybe all the things that it relies upon to go into the target org. Then you have a history of the migration in the org itself. Some of the concerns or disadvantages, again, it's pretty similar to the Force.com IDE. It doesn't have any automation capabilities. It doesn't run tests between sandboxes. You cannot modify a change set once it's been deployed to an org, and that's a useful use case because we want to have some auditing capabilities, and that's why you can't modify them. Generally, it doesn't scale well when you've got a lot of Salesforce orgs that you're trying to connect together. So it works well with a non-developer skill set, maybe more configuration than code, and it's simple to migrate smaller items or smaller deployments. So Srini showed the AMP migration tool. We'll show some more demos of this tool. So the AMP migration tool is based on Ant, which is an open source tool, and Ant is built on top of Java. It's a command line utility. What Ant does is it wraps the metadata API calls for ease of use. So you've got an Ant deploy task or an Ant retrieve task. The big win with Ant again is that it's got pre-built tasks also for source control systems. So if you want to talk to Subversion or Git, there's lots of out-of-the-box connectors that are available through Ant, and a lot of community support around Ant as well. We're going to be showing a build automation tool called Jenkins, but almost all build automation tools can call Ant scripts. And then the three files which we'll go through on the next slide that are important: the package XML, the build XML, and the build properties. I'd like to break those down into the what, the how, the where. So the package XML is really what you're deploying. The build XML is how to deploy. So it handles really the heavy lifting involved in orchestrating calls. So you can check out from your source control, you can deploy to a Salesforce server, you can commit back into source control. Various things around the orchestration can be built all in your build XML. And finally, the build-up properties is really where it's your environment variables like usernames, passwords, and the instances that you're deploying to. So here are the three files here. If you look at the build XML here, I'll highlight this SF deploy. That is the actual Ant task that we're using, and it's got some variables that we're using from our build properties. With the package XML there, you can see it's a well-structured XML document. We've got two types of components that we're trying to deploy here, an Apex class and an Apex trigger. We've named the classes and the triggers that we want to deploy. We could quite easily replace these named members with an asterisk. Using the asterisk, Salesforce will just bring across everything it finds in the local file system. So what do we like about the migration tool? It can easily be integrated with automated test and build systems. It integrates natively to source control. It allows you to run tests between sandboxes, and I'll draw your attention back to that first slide that we looked at, where there's a lot of fear in doing a deployment. Having those tests run early really makes a big difference. Some of the considerations around using Ant, it's quite a lot of setup initially, so there is some overhead before you start getting value from the tool. It does require a developer skill set, and like all the other tools, it's still limited by the Metadata API, so there are still some manual tasks, but they are getting smaller and smaller. So in summary, we see a lot of enterprises with existing build and release management infrastructures. And so whether it's a .NET, Java, or pick the development tool of your choice, there's also those best practices that easily migrate over into the Salesforce ecosystem. We'll talk a little bit about source control. So source control, also known as version control, revision control, it allows you to track changes in your Salesforce metadata. So as you may know, the Salesforce doesn't have any native source control integration, so there is nothing in the Salesforce user interface that can allow you to integrate with source control. Some of the characteristics that we see in source control systems, one of those when you're looking for a source control system is the concept of merge later versus file locks. So some systems will lock a file so only one developer can work on them at a time. Other systems will allow you to have multiple developers with a file open and then optimistically merge those files as long as the changes were in different line numbers. We're seeing two main flavors of source control systems. The more traditional is a centralized source control system. It's more of a client-server model. Tools like Subversion, Perforce use this model. And then there's a distributed source control system, which is more peer-to-peer. Git, Mercurial are examples of those, where changes between people are done via pushes and pulls. I'm going to hand it back to Srini here. He's going to show us a demo of how to connect to a Subversion repository. Hey, Srini, I think you're on mute.
I'm sorry. Yep, I was on mute. So here I have my Eclipse IDE open here. So what I'm going to do is, okay, so what we need to connect to SVN repository in first place. Since I'm using Eclipse, there is a plugin called Subclips, which connects to SVN through Eclipse here. So if you want to install it, so what you can do is help and then click on install new software. And then if you can see here, subclips.tigris.org, once you type in that URL, it will guide you through the installation process here. So that's the key requirement to connect to SVN here. So before going there, when you install Subclips, so you will have like multiple perspectives here. So this is the force.com perspective that we are seeing here. But I would like to go to the SVN repository exploring perspective here to see the list of SVN repositories that I have connected to. So that is an icon in here. You can see it here. If you have to connect to a new repository, you can just click on that button and then type in the URL here and then say finish. It will ask for username and password if it's a protected site. Then you'll be able to connect to it. So since I have already connected to my repository here, what I'm going to do is I'm going to check out the source code from the SVN and also connect to developer org using this checkout project as a project configured using the new project wizard. So I'm going to do that here. So now I'm going to select the force.com project here. And now I have to key in the credential. I have to name this project. So let me say I'm going to say it as sandbox 3. And here you go. I'm just going to copy. I'm just going to connect to my individual dev org here. So I'm using the build.properties file, which I was using to execute the AND script. So I'm just going to copy this. The credentials from there. So here now you can see like I'm connecting to my dev org and it's switching, and you can see like there is only one class called test.utils. So I would like to have that, and then I'm just going to click on finish here. Now you can see it has already started fetching. Now, okay, I'm just going to say okay. So now you can see now the SVN checkout is in progress. So what it's going to do is it's going to check out all the components from the repository and it's going to add it to my project in here. So now it has started. It should be done soon. Okay.
You've been writing a lot of code there, Srini.
Yeah, I think so. Let's see. Yeah. So here, yeah. So now it's all good. Now you can see there is next to the source there is a cylinder kind of icon, which this means that we are connected to an SVN repository here. Also, you can see some red flags in here, which means we are the code in here and the code in my developer org is not in sync. Okay, so what I am going to do is let me go ahead and then do force.com. Let me select only these two here. Okay. And then say force.com save the server. So I just want to use the source code that's from SVN, which is source of truth. So okay, I'm going to say it's okay to override the components here. So now it's deploying. So now we are all good. So now this is in sync with the one in the server. So we are all set to go. This is how you have to like connect to a SVN repository and check out from there using Eclipse. Thank you, Raj.
Great. Thanks, Srini. So we saw there how to connect to a source control repository, and again, that's all using the Metadata API to connect to Salesforce. The next progression we usually see developers take is continuous integration. So continuous integration is a technique used to quickly identify the many issues that arise when integrating code. code repositories and build servers are the core components. Let me walk you through the flow of this diagram at the bottom here, and Srini and I will show a demo of using continuous integration. But really, you've got, let's say, 2 developers working in their own Salesforce orgs developing code. They are connected to a single source of truth, which is the Subversion repository here. When they check things in, we have a build machine. We'll begin using a tool called Jenkins to take out the latest from the Subversion repository and go and build that against a Salesforce org. The important step is the output from that build, so we can notify developers if there's been any failures in the tests, been any failures just integrating the code in general. So let me talk a little bit about Jenkins here. So Jenkins is an open source continuous integration tool. It can also be used quite easily as a continuous or as a deployment tool. It has again, it's open source and it's built on top of Java. It can be easily installed using a .war file. It has pre-built connectors to source control systems. And it has a pretty robust integration with testing frameworks. So things like UI tests via a tool called Selenium, or if you've got coding standards that you wanted to enforce, you can integrate those quite well into a continuous integration system like Jenkins to make sure your builds are running and not introducing regressions. There's a wide ecosystem of plugins. I'll put a little plug for our own internal plugin, Jenkins to Chatter, so you can have Jenkins post to Chatter feeds when things are going well or not going so well. And just a little background on Jenkins. The Jenkins project was forked from Hudson after Oracle, which claims the right to the trademark to Hudson, applied for the trademark. So I'll hand it back to Srini now. We're going to show a demo of continuous integration.
Thanks, Raj. So here, as part of the continuous integration, what we are going to do is, so you can see, we have a requirement to populate the has opted out of email value in the contacts based on the value in account. So whenever an account is updated, what I want to do is I want to get all the related contacts and then update this value from the value in the account. So this is what I'm going to do. So for that, what I have done is I wanted to do it now under the trigger. So here you can see I have created a trigger for this. And also, like a good developer, what I have done is I have created a test class as well. You can see this now. I have went ahead and saved this, so the code is properly compiled and saved to the server. However, you can see there is no this SVN icon next to this component. So that means it's not committed to SVN yet. So what I'm going to do is I'm going to go ahead and commit this to my repository here. So let me go ahead and do that. Team, and then I'm going to say commit. So I'm going to select all the 4 and new trigger added. So now it's committing to SVN. So in the meanwhile, let me go over Jenkins. In the meanwhile, so here you can see, as Raj spoke about Jenkins, it's a continuous integration platform, and so here we have a job called dev build. So what would happen is, now you can see there is a job that has kicked in and it's waiting for the next available executor. So what this job does is, this job is triggered whenever a commit is done to SVN. So as I have committed my changes to SVN here, so now you can see it's all in sync. Now you can see the SVN icons for the newly created components, and it's all set. So what happens is, whenever I commit anything to SVN, this job is going to be automatically triggered, and then it's going to run all the test cases from there. So in the meanwhile, you can see here, you can see the timestamp also. This job has started running here, and when you click on the console output, you can see what's happening here. In the meanwhile, I will not wait for this job to complete. In the meanwhile, I'll give it back to Raj, where he is also going to make some changes, and we'll come back and see what the output result is. Raj, would you like to take it from here?
Sure. Thanks, Srini.
Yeah. Yeah.
I want to draw our attention just back where we are in this demo here. The code has been checked in by Srini. He's sitting up the top here. It's been checked into Subversion, and Jenkins is going off to build. I'm developing a similar set of code here in my own Salesforce org. So similar to Srini, I've got a trigger on the account object. I have a requirement that all of the contacts under account should have the same mailing state. I have some business processes driving off that mailing state. Just like Srini, I've got some tests, creating my own test data and doing some asserts. So I'll go ahead and I'm ready. I've tested these locally. I'm ready for these to be committed into Subversion to try and integrate with fellow developers. And as that commits, I want to draw some attention to the actual build XML that we're using here. So you can see that's committed, everything is in sync. So what are we doing when we're using the dev build and deploying? So we talked about this ant target here. Got a username, password, a deploy route. That's all fairly standard stuff. The two important components here are run all tests. So we've got a flag set to true, so we always want to run our tests when we do a check-in. And the other thing is check only. So what this flag will do is it will deploy your components, run all your tests, and then roll everything back. And so nothing ever gets deployed actually to the Salesforce org itself. Just going to go back to the console output from Srini's test, and we can see here the asynchronous nature of the Metadata API. His tests have been running here, and they completed successfully. Going to the output from what's going on with me, you can see Subversion has recognized that these files have been added, and that's come out in the console output. Those are the trigger and the tests that I've added. And it's going to go ahead and run my tests. Let's take a little bit of a look at the build here in Jenkins. So there's some fairly standard stuff here that we can give the build a name. We've got integration with source code out of the box here with Jenkins. We can add multiple locations that we want to check out from. There may be a requirement to check out from a trunk to get the source code, and maybe some build files to help with maybe the UI testing framework. We've got it to listen for changes. And here's where we invoke ant, and I showed that build XML, what we call dev build. And finally here, some notifications, so we can add multiple notifications. I mentioned earlier coding standards, so Sonar is a tool to do coding standards, and it can analyze your code, so make sure we've got enterprise level coding standards adhered to. We can invoke ant, and generally we can do a lot of things just through executing a shell here. Let me go back to the build here. Still running our tests. And Srini will show these in a moment, but we've got multiple builds here that we're able to build up and have triggered on different scenarios. You can see the build is complete here, and it has failed. Let's look down here. It looks like the code that I checked in has hit a limit. So the limit here is too many DML rows. We're only allowed to insert 10,000 per Apex invocation. we've inserted 10,001. So this sometimes may look like a contrived example, but you'd be surprised with how many times that I've seen multiple developers work on a single trigger, only to find out on deployment night that they're inserting too many records or they're querying too many records, and they find that out pretty late in the development process. Not to get too much into development best practices, but it would be probably a good idea for Srini and I to communicate and also to have a single trigger on the account record. So I'm going to talk a little bit about build pipelines. So let me walk you through a typical build pipeline that we see. We'll see that the first part here, Srini and I showed you that we've checked into version control. We're going to build our unit tests. We had some failures. That comes back. The development team then goes ahead and fixes those issues. Checks back in. It builds your unit tests. Then we go to the next step and we try some automated acceptance tests. So we've built some UI tests that get called from Jenkins. We get some failures back from that. We go through that whole flow again. This time it makes it past the automated acceptance tests, and we get to user acceptance tests. Those are usually manual. We'll get some feedback, and we'll go all the way through again to the release. Let me walk you through a build pipeline here. So what we're trying to show here is an agile or a scrum team working on regular sprints, but then integrating with multiple development streams. So we'll start off with sprint 1 here. It started off in dev. 2 weeks go by. Sprint 1 moves into the QA environment. Sprint 2 starts in the development environment. At that time, we've got a requirement that we want to do some innovation in a separate sandbox. So we take the latest copy from the dev sandbox, and again, this is all through source control, and we create an innovation sandbox. We fast forward 2 weeks. We find an issue in sprint 1, and so we need to fix that. And the place where we're going to fix that is this QA fix environment. In this environment, we've got a separate source control system and a separate sandbox, and we need to fix it in there because in sprint 2 is going on development, and we don't want to put that code into sprint 2 or the bug fix in sprint 2 because sprint 2 is not ready to go to the next stage yet. So we fix in QA. That passes in QA. Once we're confident there, we put that change into the sprint 2 environment. And just to be clear, these arrows here in green and these arrows here in black, this is all handled by Jenkins, and it's doing these checkouts from source control and deploying them using the force.com migration tool to these different environments. So we fast forward another 2 weeks. Sprint 1 is ready to go into production. Sprint 2 goes into QA. Sprint 3 starts in dev. And then, so after 4 weeks, the innovation team is ready for their stuff to go into production or the next stage. So innovation goes into this roll-up sandbox because they've been away for 4 weeks. A lot of changes have happened. So in this roll-up sandbox, they pull the latest from sprint 3, make sure everything runs okay. We run all our tests again using automation, using force.com migration tool and Jenkins. Fast forward 2 weeks, sprint 2 goes into production. Sprint 3 and innovation are now ready for QA. Sprint 4 starts. So you can see there with some automation setup, we can have multiple and parallel development streams and main releases all rolled into one. So hand it back to Srini here. He's going to show us how to actually deploy between environments.
Thanks, Raj. Thank you. So here we are in Jenkins here, and I'm going to go over some of the jobs that we have configured for deploying in multiple environments. So here you can see like there is a job called dev to QA. So we all know that like Raj introduced his own triggers, and then it threw an error, and then we fixed it, and then we sent it back to QA now. So and everything is good now, and we are ready to move this to QA here. So what I'm going to do is here, when you click on the build now, okay, we are in dev to QA. When you click on build now, what it's going to ask is it's going to ask for a new branch number. So why do we even need branches here? The need for branches is it's just to version the source code here. So as part of the build process, what you can do is before deploying, you can retrieve all the components from the server, and then you can save it to a repository as a backup. Um, and if there are any issues or anything in the build during the deployment, then what we can do is we can just go back and um, push the source code that we retrieved from the server, so that we can have that as a rollback strategy. So here, what I'm going to do is I have created a new branch called 7.0.1 here, and then I'm going to start the build. So okay, the build is waiting here to start. So in the meanwhile, let me go over this project here. So as Raj went through this one, you can give a name. Then there are like some other optional things here, where if you want to discard some of your old builds, then you can go ahead and do it here. And now, where during the dev build, it was like kickstarted whenever an update is done to whenever a commit is done to SVN here. But this is a parameterized build, so it's going to look for a parameter here. So that's why it has to be like invoked manually. So we are doing it here, and then we are creating a new branch. Here is the variable that we are using. I'll show create branch. This is the variable that we will be using in our build.xml to specify from where the source code is to be taken from. And here, as you can see, we are still using Subversion as a repository here. And here I am actually like connecting to two repositories here and checking out files from two repositories here. Then again, you can see which is the job that I'm kicking off here. And you can also see the build file. Where is the build file? The build file is in build.xml, build/build.xml. And once it is successful, then it will send an email to Raj Chauhan. So if you can see here, the build is going on, and let's click on the output. So here it's all going on here. I'm not going to wait for this to complete. In the meanwhile, what I will try to do is I'll try to go over some of the build.properties here. So here, this is the target that we have invoked through the job. So and here you can see the create branch here. So this is the variable that we have defined in our job. So based on the branch number that you give, it's going to create new directories, and then it's going to put in all the code in there. And here you can see all this SV and username and properties and all that. So all this comes from the build.properties file. Okay, so and then this is the path and everything. And here you can say deploy to QA. And before even deploying to QA, what you can do is you can run it in another environment where you just want to validate whether the build is going all right or not. So those are the things here. And in the meanwhile, before we go to the QA to production build, Raj, do you have anything to add as part of this, Raj?
No, I think, yeah. Thanks, Srini. I think the key thing here is when we're creating those branches, we have a way to see exactly what's changed through our environments, to look back at each release to see what changed. And then also, we've got a way to roll back. So if we find that the build hasn't worked, we can use the snapshot of production. There is a note here that to actually delete components, you do need to use what we call a destructive changes XML. That's available through the link on the webinar. on how to use that destructive changes XML. We don't have a demo of that. But between those two items, we can get rollbacks fairly straightforward.
That's great, Raj. So thanks for that info. So here, in the meanwhile, since the build is going on, I'm just going to go over another project called which QA to prod. So this one, what it's going to do is it's going to deploy the code from QA and then deploy into prod here. So here, what I have done is, let me go over this. Okay, I'm just going to go over the configure a little while here. And here, I said the build is parameterized before. In the earlier one, I keyed in a branch number. But here, what we are going to do is we are going to select one of the branches that we have already created here. So let's go ahead and see what's going on here. I have clicked on build now. Now it's asking for which branch that you want to deploy from. So now this is the new branch that we created earlier. And once when you select and then click on build, what this job is going to do is it's going to pull in the source code from the specific branch, and then it's going to deploy it to the server. So since we have already tried a couple of things, I'm not going to go and do this build here. So this is the various parameters that you can pass, and so how to move from individual org, individual sandbox to an integration org, and then to QA, and then to production. So thanks, Raj. Thanks for the time. I'll give it back to you.
Great. Thanks, Srini.
Yep. Yep.
So as we talked about earlier, we're going to just cover a couple of features that we found interesting in the last two releases of Salesforce. One of those is a pilot feature. This will enable a lot of our customers who have tests that take a long time, maybe in the region of maybe an hour, hour and a half sometimes, with very good unit tests that test at large data volumes. Fast deploy will enable you to only run specified tests. We do still mandate the code coverage requirements, so 75% code coverage per class, and it must cover the actual code that you changed. And again, this is all through the force.com migration tool. It won't be available through change sets in the pilot release at least. The other one that seemed like a smaller item that got released in summer 13, but this smart user matching. So previously, when you created sandboxes in Salesforce, you'll notice that all your users got an appendix here of .dev or .full. That used to cause some issues when you're deploying between environments. And now Salesforce interrogates this user and finds out that actually these are all the same user as you go through those environments. It certainly looks like a small change, but it's helped a lot of deployments. I mentioned the tooling API. So the tooling API is used for what we're seeing is developing user interface tools to interact with development artifacts. It can be accessed via SOAP and REST, and our very own developer console has a lot of it built on top of the tooling API. If you look at your logs, and you can see those actually going through the tooling API. So in summary, what we've covered today, and just to go back, we've covered a lot of code and a lot of demos here. Srini and I will post these items or links to these build files, so hopefully you can try and replicate what we showed in these demos. We talked about the API and its characteristics. We talked about the tools to access it. Then we walked through, we went through using Ant, using source control, moving into using continuous integration, and then what's sometimes called continuous delivery, but having an automated delivery process. Here are some resources. These links will be available on the webinar show notes. I want to draw some attention to some upcoming events from the developer team. October the 10th, we've got an Apex Code Talk. October the 16th, we've got event notification options for Force.com apps, and another series that we've been doing around mobile SDK. October the 23rd, we've got an intro to the mobile SDK in building Android apps. Dreamforce is coming up. I want to draw your attention to special developer price we've got, 799. Use the promo code here. Again, this will be available in the show notes. And we'd love to hear your feedback. So please let us know what you liked, what you didn't like so much of this webinar. We'll definitely take it on board. So we've got some time here. I'm going to go through some questions that we've got through the webinar. Let me start off here. So we had a question here: is there a list of components that can be that can and cannot be deployed by Ant? There is a link, and we'll include that in our Metadata API and a list of content that's not available in the Metadata API. I've had a question: is what is the difference between save to server and deploy to server? And that's on the IDE. Let me just show that real quick. The save to server is a connection that you've got when you set up your project. So if you go to properties and your force.com properties, whenever you save to server, it will always go to the one that you originally connected to. And deploy to server is actually deploying to another server. And as I mentioned before, this will always ask you for a username password. So this is deploying from maybe dev to QA. Looking at some more questions here. The question: can you schedule a daily build to occur in Jenkins? Yes, you can. So we've had it configured to build on every check-in. That may not be the best use case for all of our development environments. Maybe you just want them to build daily. So Jenkins uses a similar tool called, from cron, which if you're familiar with Unix, you can specify the times when it builds, or the days that it builds. If it's Monday, Tuesday, Wednesday, Thursday, Friday at 5 p.m., you can do that via cron. So if you look up CRON cron, you can do that via Jenkins. Just looking at other questions here. So some of these questions will probably take more interrogation from Srini and I, and some of them may definitely warrant a post on Developer Force. So we will go through some of the questions that I haven't, if you've posted questions, some of the questions that I haven't talked about, and give questions that in the next couple of days. But I wanted to wrap up the webinar. Thanks everyone for your time. Hopefully you've got some use out of this webinar, and see you on some other Developer Force webinars. Thank you.